Hello, and welcome to another game development broadcast for Project CSK. As usual, of course, I am the creator of the project, and the online name that I go by is Des. We're going to continue working on the project like we've been doing for quite a while now. And there's been some good progress, and there's been some challenges along the way, of course. And there's also a correction that I want to make to something that I said earlier as well. I mentioned, I think it was in the last broadcast or in a broadcast before that, that I was talking about performance and whatnot. And I made the assumption that the Unity particle system uses your GPU. It actually does not. The standard particle system uses your CPU, which I only found out about not too long ago. So I'm going to be definitely learning more and more about this. And as I learn more about Unity as a whole, as a technology, as what it has to offer, which is quite a lot, I will definitely be making some corrections to some of the previous things that I've said if they need to be corrected. But so to clarify though, shaders, of course, use the GPU because they're code that's meant specifically, or whatever type of system that they are. It's purely around the GPU. You can interact with them, of course, to some degree, but it is generally shaders are meant for GPU and GPU intensive things. Then there's the default particle system, which uses your CPU, and then there's VFX Graph, which is what I'm going to be using a lot more of now that I'm getting a little bit better understanding of it, but still entry level. That is definitely what I want to be using, and it's similar to that of the particle system, but a lot more advanced. And I do mean significantly more advanced and powerful. And they both have their pros and cons, but yeah, so I'll be using a VFX graph, and I would likely be dropping the particle system in the way that I'm using it, unless there's a use for it. I don't know. We'll see. We'll see. But I wanted to make that clarification. Anyway, so what I was working on in between the last broadcast and this broadcast was the object pool system and trying to get that working correctly. And I'm still working on it, to be honest. It's something that was more complex than I had initially thought. And because I just don't have the time to really sit down and really dig down deep into it, it's difficult to get into the state of mind. It's difficult to get into the zone and see the big picture. So I keep like scratching the surface, and then I'm out of time. I got to go do something else, come back into it, then I need to get into it again, right? Because it's pretty deep logic, and it's not something that I can just jump into and out of. I need to really allocate a large period of time, which means basically my progress will be limited to weekends on that kind of logic, because I generally try to do so I try to do the lighter stuff during the weekdays when I have only little smaller slots of time. And then on the weekend, when I can allocate larger chunks of time, I try to do the more complex things, or the bigger systems, because you have to get into the zone. You really have to get into the zone to be able to implement functionality that's multi-layers deep of logic, because then it's easy to make a mistake or easy to make an assumption that may not be correct. So then you'll have to backtrack on later, which then can cause a rippling effect inside of the engine or the architecture to different parts of the project. So it's definitely undesirable to have short periods of time to attempt to do complex logic. That doesn't mean you can't do programming in short periods of time. You definitely can, but you have to structure it more. And you shouldn't be doing complex things or attempting to do big system kind of changes or implementations, because you're going to get pulled away midway. And that's exactly what happened to me. So anyway, where I'm at right now is that I put a bit of time into it as much as I could. I figured out some of it, but there's still more of it that's not yet figured out. And you'll see what I mean shortly when I give it a run. And then I need to kind of get into the mind frame and then pick it up from where I pretty much last left it off. And we'll continue right from that point. So let's jump into it, and let's see kind of where we're at. We're on the right screen. Yes, everything should be working. Okay, let's run this. and see where we're at. So I'm still using that that tool that I made is so useful. Oh wow, the editor window thing that I made. So this thing over here, it is so useful, incredibly useful. Okay, so what we're going to be doing is let's scale that down. I can probably just, I want to leave that there kind of because it helps me a little bit in terms of visualization and whatnot. We'll scale this down. Okay, so I want to allocate most of the space for here. The Flash client, I'm just going to get rid of that. So that's out of the way. Okay, so let's reduce this a bit more, maybe increase this a bit more. Okay, so we're good. All right, controller is connected. Okay, so what happens is, so you'll notice, and specifically, let's focus on the, because that's what I've been working on, is the destroyable objects. There's 6 on 6 instances total, and those are the gray blocks that I put down, and all 6 of them are currently on the stage, 0 in the object pool, and the recycle count that's not been implemented yet, so you can just ignore that column. Okay, so we'll go log in. Okay, logged in. We go to game room. Okay, so at this point, I think this is still correct, and that we used those 6 out of the pool, and then we added 11 more. So there's 11, there's 17 instances total, and all 17 of them are on stage. So what happens here? We need to go to the next round, and I'll show you what I mean, what happens here. And I still don't know what is causing it, because if I did, I would just fix it. But I'm implementing a better solution, which I'm hoping will, one, help clarify everything and will likely solve these things anyway in the path of its implementation, because it should address these things. So the count that comes out is incorrect. All right, so I will need to just kind of play it through a little bit. So we're going to destroy all the blocks. So right now it says that there's 17 instances total, 13 are on stage, and there is 4 in the pool. So as I destroy more of these, they go from the stage into the pool for us to be able to utilize them at a later time. And that's the key thing. So I'm going to need to clear all of this. So we'll continue to just clear it out. Like I said, I'm not exactly sure what causes it, but so this is roughly the point where I can replicate that. So we clear it, right? So all the destroyable blocks are cleared. I put 1 down. So right now, all 17 are in the object pool, right? And there's 17 instances total, but all 17 are inside of the object pool. So if I use this, right? So we put 1 on stage, we got 16 in the pool, and we got 17 instances total. So that total instances is what I want you to pay attention to. So I'm going to KO everybody. Okay. All right. So we have 17 still in the pool, right? 0 on stage, 17 in the pool. Remember that. So let's focus onto this. When the next round gets built and we get that information from the server, now we have 32 instances total. We have 15 of them on stage, and we have 17 in the pool. So you can see that this number doesn't add up, right? Because if there's 15 on stage, then what should have happened was that there should have been 17 total. You subtract 15, there should still be 2 in the object pool, right? So this information is correct in what is being displayed, but the logic of where this information is being pulled from is not correct. So how do I know this, right? Because if we go into the object pool and we look at this specifically, sorry, not that one. I can't see this text. It is the cube block, yeah. This one here. Cube block, I believe. Let's double check that before I make any further assumptions. Okay. So those are not there. These are fine. Okay, so we'll just select one of them. We'll select this one. So you'll see that the naming convention is cube underscore block underscore s underscore blah, 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 blah. Okay, so with that, when we go over here, cube block, so if we say cube and filter it, underscore block. Okay, so these are the ones that are on the stage, which is correct, right? And you can see that those are the ones that are on the stage. So how many do we have in the pool? We have only 2 in the pool and they are disabled, right? So that means the total is 17 total. That's correct. 17 is correct in that it should be 17 instances total, 15 of them on stage and 2 in the object pool. So this information that's being displayed in the object pool is not correct. And this is where I basically, how far I got it to before I reached kind of my time ran out and I ended up walking away from it. So this is what I want to solve because I really need the object pool to be robust because this is a core part of the game system. And I want it to be used in this sense, in that all of these objects, right, it doesn't matter what type of object they are. If they are a poolable object, I want to be able to throw them back into the pool and have them be stored into the object pool. So then we can pull them later. So then you're not wasting resources in creating new instances, not wasting resources in destroying something and having garbage collector clean up, and not wasting RAM, because the more objects that you create, the more of the instances, the more RAM they consume, and so on and so forth. And it's a performance thing really as well. So I need to get this working correctly. And once I get this working correctly, I'm going to be very happy with it because it's going to be used extensively throughout the entire project. So yeah, that's where we're at right now. And what I did is I went to the object pool itself and I implemented a, so we'll just leave that running. I implemented a new class. So it's another one of these that I mentioned in the previous broadcast that I'm going to make. So this is what I call a dictionary list. So it's a dictionary that holds a list of objects which will be defined when you create the instance of this. So far this has been working, or sorry, so far the implementation of it went smoothly, but I haven't had a chance to really implement it and test it to see how well does it work. And does it solve the current challenge and dilemma that we're having in the incorrect count? I believe it will, but this is how far I got it to. So when we go to the object pool, sorry, not that. When we go to, I keep clicking on the wrong thing. I don't want that. I want this. There we go. Okay. So what I did is I created the new pool, or pool new. So this uses the dictionary list, and what we're going to be getting rid of is replacing the old pool, and in the process cleaning this logic up. And I want to also start using a, I think I haven't fully decided on it yet, but I'm going to use a scriptable object, I believe, that will be my lookup table for objects in the object pool, so that I can just swap them out in that way instead of swapping them out and implementing this kind of logic in code. Because if I use the scriptable object method of what I'm thinking, it'll replace all of this logic. And it'll make it very intuitive and a lot easier to manage. Like this, it doesn't need to be this big. Right now it's about roughly just over 600 lines of code. I can bring this down to probably 200-300. I think I can do that, and it'll be a lot cleaner, and that's what I want. I want to achieve clean and easy code, so then I don't run into these kinds of logical flaws. Because as I continue developing on the project and it grows to be bigger, bigger, and bigger, there's going to be more complexity overall. So if we can simplify and keep everything kind of modular and structured in a way that they're easy to make sense of things, then it will alleviate some of that complexity, and it'll make fixing logical stuff a lot easier down the line. So that's kind of the goal. Anyway, so this is where we're at. How far did I get? I added this to this class, and I added this entry, and this was the final thing that I did. So it's really not been implemented yet. What we're going to be doing is implementing this, and that will of course replace pretty much this, and then I need to add another one to the get, and so on, and it'll just cascade. So I'm hoping that using this will fix any potential logical flaws that are coming from this. And I don't understand why it's using that count is off, because if we go back to it, right, the way that I implemented, oh, no, count's still off. Yeah, so this is still not correct, because they should match, right? So it's creating extra objects in the pool, which I don't know why, but at the same time, I mean, it's clearly a logical flaw. If I knew why, I would have solved it already. But that's what we're going to solve, because I don't want it to do anything like that when, or sorry, I want to avoid those kinds of things. So the information that's provided should be mathematically accurate. And yeah, so that's where we're at. So let's jump right into it. Okay, what I need to do is this. I haven't tested this dictionary list yet. And it's got some really nice functionality to it, in that it'll alleviate some of this complexity from here, and it'll move it into the dictionary. So then I don't have to manage a two-dimensional, or sorry, a dictionary with a list inside of it. I can just manage all of the objects using this, and this object here, the dictionary list, will do the internal management of managing the list and the objects that are added to the list, or the lists that are added in terms of the categories and whatnot. So it's basically a separation of logic, where we let the dictionary do its thing, and we manage the dictionary information that goes in and out of it. Okay. So yeah, from what I can see here, debug stuff, I'll leave that in. So it came down to this. All of this, for the most part, is getting replaced with this right here. So it's going to be much better when we get to that point. But it's still not being used yet, right? And that's the key point. So, okay, when we go here, we go to add. We say the type, and we add this, and we let the dictionary manage it. And then we call this function stored in pool. So what this does is that it reparents it under the iPoolable game object, so that if you destroy whatever object it was previously a child of, like something that's a part of the game room, it will not affect this object. This iPoolable object is now under the it's under the transform of the pool, and the pool is an object that is told in Unity, do not destroy on load. So when we change from scene to scene, this is a persistent object. So we can safely put stuff under it, put children under the parenting of it, and they will get carried over from scene to scene or whatever. And then whenever we want to use one of them, we pull from that, we reparent it, and we remove it. Now this other dictionary, this is used mostly for metrics right now. This is to tell it that this object is being used. So we remove it. We remove it from this dictionary if it exists. If it does not exist, then that means it doesn't exist yet. But it's still safe to call this. However, if we ask it to remove something that doesn't exist, it will give us a warning output, I believe, if I'm not mistaken. Key does not exist. Yeah, so it does give us a warning output. Okay, so we should be good on that. So this looks good to me. This looks clean. Okay. So we're not ready yet to replace this, but we will comment this out entirely and replace it. But what we need to do now is to do the get. So let's do the same thing. If show debug is true, I'm just wondering if I can copy paste that. Yeah, I can copy paste it. Okay. Okay, so this is going to be the new one. What we're passing in is, let's see, how does this logic work? If contains key. Okay. So what we need to do is check. Let's do the test stuff first, just to get it out of the way. Wait. No, it's wrong. Oh, huh. I was looking at the wrong one. Okay. We need to comment this out. Okay. And this does not exist right now. So if we're getting this warning, then it's notifying us that it does not exist yet. Right? Oh, I could have just copied this. Let's do that. If show debug equals true, I don't think I need it in both the beginning and after. Because what this does is it checks if it doesn't exist, it tells us. Then it goes to add. It adds it successfully. We store it in the pool for the metrics. Then we output the type and we output the, oh, we get the count. Okay, yeah. So we don't care about that in the get. In the get, what we want is actually, we do want to do a similar thing, but not exactly. What we want to do is we want to say that if key exists, okay, or sorry, if key does, I keep pressing the wrong button. Show debug equals true. Pool, if key exists, we'd say key does not exist. Oh, if it equals false. Right. So if it equals false of this type and show debug is true, key exists equals false, we say that this object pool type does not exist. Okay, so that's correct. So if it does not exist, then there's really nothing to do. I see. Okay. So what we can do is let's flip this around actually. So then if it does not exist, what we do is we create it. Okay, so if it does not exist, then that means we need to create the category. So what we'll do is say pool new dot add, and we're going to create the object pool type category, and we're just going to leave it. Wait, that should not be giving me a warning. Oh, okay, so I didn't do the add on a singular. Okay. So what we want to say is public list of T object. And we want to say add. Wait, no, we don't need to return this. I'm still thinking that I need the list. I don't need the list. What we want to do is we just want to create a blank list is all that we want to do. So what we want is T index A, and then what we do is we just create the list. Just this part. But before we do that, let's verify first that it does not exist. So if dictionary dot contains key equals true, then there's nothing to add. Okay, but if it does not exist, so we create a new list. No, that should be. Wait, I already did that. I'm not exactly in the right mind state to be doing this right now. I'm feeling a little exhausted at the end of Friday. And then we add it to the dictionary. Okay. Check that. Check if it exists. Okay, so if it exists, right? If it exists false, so if it does not exist, then we go and we create a new list and we add it to the dictionary, and that's all we need to do. However, if it does exist, then we don't need to do anything. Okay, that's all we need to do there. So then let's see. However, if it does exist, okay, so if it does not exist, if key exists, I'm not thinking clearly. I'm really not. Okay. So all we need to do is we need to make sure that the list or the category exists before we get to this point. That's all we need to do. Nope, that is right. Where is it? Wow. Okay. Let's have a look at this logic. If exists equals false, we create an empty list and we get a new instance. Right. Okay. If it exists and the count is greater than 0, right, we can pull one. If count is 0, then we create a new instance. Okay, so we have 3 conditions here. Okay, so this is why I was getting a little confused here. So how can we clean this logic up? So if exists equals false, then it doesn't exist. We need to just create a, and we don't even have to do this. I want to do this for metric. So then that means that there's going to be usage of it later. So in the tool that I have, which is this little tool here, it'll show up in this list. It'll show up as 0 in terms of objects in the pool, but it will show up, sorry, this list here, or this tool here, should I say. I just want it to show up in here because I really want to expose this information. It really helps me visualize everything. So back over here, what we do is we create a empty category, but we still haven't returned an object yet. So at this point, if pool new dot count of, so if the count of object pool type is less than 1, let's go with less than, no, it wouldn't be less than equal, would it? No, it wouldn't. If it equals 0, create new. So this condition will happen, of course, because we just created this. Otherwise, if it was previously created, it'll skip over this part. However, it'll still hit this part, and it'll do its validation check. If it equals 0, we need to create new instance. However, if it exists, we need to retrieve. And that's, I think, what I did here. If count is greater than 0, oh, I see. I just did the comparison a little differently. I did greater than 0 instead of it being equal 0. That's fine. So we got a false, false, true, basically, condition. Over here, we have a false, true, false condition. So that's fine. Pretty much achieves the same thing. Okay, so then ultimately what we want is we want this. And we're going to make that. So what we want to do is create a new instance, which we will do by calling this function. Okay, so that will create a new instance. I'm not too concerned about this error. Actually, I do want to temporarily change that. So I'll change this to a 2 for now. We'll change it back later. I just don't want the variables to conflict right now. Okay, so then if it's greater than, yeah, we want to retrieve. So poolable object 2 equals this. Okay, that's so much cleaner than this. This is part of the reason why it gets confusing. So then at this point, then we can return this variable here. Okay. So that's what we can do. So again, we check if it exists. If exists equals false, we just create the category. So now we know at this point the category exists. If count equals 0, so whether it was existed recently or if it existed before, if the total count within that category equals 0, we need a new instance, right? However, if we already have it, then we want to retrieve the next one that's available to us. Yeah, that's exactly what we want to do. So let's have a look at these functions too. I just want to see what they are. Let's look at retrieve and remove. Retrieve and remove. Okay. Retrieve and remove. Okay, so it goes to the pool, remove, add for tracking, return it. Okay, so that seems easy enough. That gets called twice because, oh yeah, we have it here and here. Okay, maybe I'll just duplicate that function and change it because I'm going to be replacing, or I'm going to be removing a lot of code from here. Yeah, I think I'll duplicate it because I want to change this logic. I want it to use the new dictionary. We will rename this to old. I can't spell old. That's funny. Okay. And then we'll copy that. The one that's old, of course, will get completely removed. We'll call this one 2 to match that variable. Okay, so from here, what do we want? We want to underscore dictionary, underscore pool new. We want to get object pool type. So we want to get the next one. Does this auto remove? No, it does not. Let's add another condition. No, let's make a new one. We'll call it get and remove. So public T object get and remove. Yeah. So we'll say T index A. And what it will do is basically the same as this. However, index is going to be 0. No, I like index being an optional parameter. So we'll leave that in. So, but what we're going to do is we're going to get the reference. So we'll get T object, which will be object equals dictionary. Actually, it'll be pretty much this. No, I think you can do dictionary dot. We can do dictionary A and then say remove, and it should return. Does a list remove return the value? If we say remove I don't remember. How does it work? Oh, it just returns Boolean. No, I want it to return the object. Okay, so that's not how it works then. Okay, so what we will do then is we will do exactly this. So instead of this, let's remove that stuff. Index, so we get it, and then we will call a dictionary A. Do I not have a remove function? Okay. Whatever. So we'll do a remove at, and it will be index. And then what we're going to do is return object. Yeah. So we'll have a get and remove. So this way it does this logic for us inside of here. So we can do a get, or we can do a get and remove. If we don't pass in the second parameter, it'll default to 0 index because it is a list. So a list, a 0 index will be the first one that's available because we're adding to the end. So we want to remove from the beginning, right? So that should, in theory, get us what we want. So instead of get, what we're going to do is do a get and remove. And that will give us this object. So that eliminates this. Okay. So we get the reference to the object, remove it from there. Then we say, we call the other dictionary and we add it to this one based on its hash code. And this one is used mostly for statistics. Okay, so this should get us our results. So then this would be the object that we would return here. Okay, so let's have a look at this one now. Add stage object to tracker. Oh. Wait, what? I think I just solved the bug I was having before. I'm double calling this. I'm doing this twice. You can see that, right? So this that I just added is the exact same line as this. Okay. So that solves that. Wow. Okay. And this is why it's better to run or to have cleaner code that's more easy to read. Because now it's obvious to me that that's the bug. That was it right there. It was that line. But with this new dictionaries that I'm making, the dictionary 2D and the dictionary list, it's not going to be like, it's going to be so much cleaner that bugs like this, if there is any more, they're going to be a lot easier to diagnose moving forward. So I'm still going to continue on this path. And I'm like, I am committed to replacing the old logic with this new stuff, because who knows what other logical flaws exist. So that makes sense also why it was double counting when the objects on the stage were correct, the objects in the pool were correct, but the statistics that were being pulled were incorrect. So that was the flaw there. That's why there was no errors. There's no nothing. It was just the dictionary that was used for tracking. Okay, so no, that's great. I'm glad I looked at that. Okay, so since that calls this, so this add to tracking is redundant. All I need to do is call create object type. Yes. Okay, so let's have a look at this one now. Okay, this is going to get replaced. This is just a switch statement that calls a function, and this is what I want to replace because I want to change this over. I never intended for it to be like this. This was my first kind of iteration of it, and it just stayed that way. I never had a chance to kind of fully implement it. And the reason for that is because the requirements weren't fully defined yet. So I couldn't commit. So I decided to just stay with something instead of change it and then change it again and then change it again in the future. It didn't really make sense. But now that the requirements have been more or less defined to what I need right now, this is obsolete. This method of doing it is obsolete because all it does is it calls a function, and all of these functions, these ones down here, they're all the same. Like they're identical almost, with the only difference being this part here. So the line that points to the prefab. And there's no need for that, because what I'm doing also is that I am I'm basically creating a game object by searching for the prefab. So if this prefab directory gets changed, right, this will also break. But what I'm thinking is that I'll make a scriptable object. So I'll make a list, because you can't do, I don't think you can make a dictionary into a scriptable object just because of the way it's inherently created. I could be wrong, so don't quote me on that. But I think that if I was to make a scriptable object list, right, that would then contain all of these, all of this stuff. This would all get removed. All of this would, oh, I use these as my keys. Okay, so I'll need to redo the keys then. I'll need to redo my keys. That's fine. That's minor in comparison. Okay, so this would all get removed, right, in the way that it's being used. Okay, this one here, the old dictionary, gets removed. This is the new one. This is the statistics one, right? That's the container that doesn't get destroyed until the end, meaning end of the application when you go to exit, or game and application. In this case, they mean identically the same thing to me at this specific time. So you'll have to forgive me if I'm using application when I should be saying game. It's the same thing to me right now. Okay, so that'll get removed. These new ones, yeah, this will significantly clean this up. I'm actually really looking forward to this. We're just not there yet for me to switch the code over. Okay, so then we call create object by type. This I will change later. I'm not going to change this now. These functions, I will remove them later. I'm not going to change this now. So I just need a new key system. Something that I can easily access. I would really like to... How could I do a key system that's intuitive? I'm not sure, because there's a lot of options. That's the challenge. It's not that there's a lack of options, it's that there's a lot of options, and I'm not sure which one would be ideal. Because what I'm thinking off the top of my head is, because the object pool lookup table would be a list. A list on a small number of devices is okay, or a small number of entries is okay. But on a large list, it is not good. You don't want to loop through to find stuff, right? So what I would do is, on the start, on the creation of this manager object pool, it would look at that list, which is a scriptable object, right? Take it, loop through it once, and make a dictionary of it. And that's where our key system could come in. then we would need to be able to cross-reference the two. Okay, I still need to figure it out. But anyway, that's the direction we're going. It's not all going to happen at once, of course. It'll happen over time. Right now, the goal isn't to rewrite the whole thing, of course. It's to fix this and get the object pool system working correctly so I can continue to go back onto the map part of it and then redo those and clean that logic up too. So then these areas that I've touched recently, the logic is going to be clean, it's going to be intuitive, and it's going to be free of bugs and any flaws. That's the goal right now. Okay, so with that said, let's move on to our next one. So we check these functions. Add is good. Create is perfect. This one is good. Create is, yeah, okay, I have seen it. So this will get, all of this would get removed. And this too. This doesn't need to even be there right now. So this whole thing would get removed. Okay, what else is there to remove? Now, remove, when we call this, remove object reference. Remove object reference. Okay, so that's for debug. Okay, so let's add that in. I want to carry that over. I like having a debug option. It really is helpful sometimes, not always. Okay, so if show debug, so if show debug equals true, okay, is in pool. Okay. So this needs to be rewritten. Okay, let's duplicate it and we'll make a number 2 of this as well. So this one will be the, before we do that, okay, so that's going to be replaced with this one. Show debug is in pool and remove from dictionary. Okay, so this is going to be changed. What we're going to be doing is just saying remove. So pool new dot remove. That's all we need to do. That's what's great about the new pool or the new class. It does this stuff for me. We need to say remove dot object pool type and then this. Oh, okay. I thought I had that. Okay, so we'll need to override this function. Is it override or overload? I forget. So this one is going to be of T object. If it contains key A, false, return. And we will say underscore dictionary dot, sorry, not dot, dictionary index A dot remove, and we just pass in B. Yeah. Okay, so that should solve that and makes it a lot simpler. Okay, so that's our remove function. So this will get removed completely when we're there. Is in pool. Where are we using that? We're using that only here. So that means that this would get removed as well. This whole function is now redundant. Remove from dictionary. This is also in the old, so that this also gets removed. So these ones, let's mark these for remove. Remove. That gets removed too. So this one stays. This definitely stays. That stays. This one gets removed. That stays. Destroy pool container. Okay, so we need to, oh, that's on the actual destroy up the object. So this would be from the destroy. Yeah, okay. That's not moving. Clear pool container. Why do we have this? If pool container, oh, create. Sorry, I read that as clear. It's create. No, create is fine. Create is fine. So that's where we create it. And then we say don't destroy on load. And this object does not have a parent because it doesn't need one. It's going to be marked as do not destroy on load. So it'll be moved to the other section, reserved only for those. Okay, so all of these can stay for now. I will refactor that logic later. This here, this stays. Clear all. So we need to do the clears. Because right now this is using the old method and it's not necessary. It's a very simple. So that's old. So the new one is going to be pool new dot clear all. That's all we need to do. I guess I don't need to say anything there. So this code here, all of this, that'll get removed. And then clear a specific category. So that's old. Same thing. Pool new dot clear. Whoops, nope. Clear object pool type. That's it. All of this gets removed. You can see what I mean by what I was saying earlier is that it really gets cleaned up and it starts to make a lot more sense and it becomes intuitive. Destroy pool container and then call clear all. Shouldn't it be the other way around? It should be clear all and then destroy the pool container. Yeah, that's backwards. Because if we destroy the container first and then we go to call clear all, these objects are going to be, oh, it doesn't matter because it's just the references. We're not actually touching the objects themselves. These are just the references to the object. So yeah, order doesn't matter. What's this one here? Oh, that's the actual call to it. Okay, so that's fine. Okay, so what do we have here? Clear. Okay, we already discussed this. Construct, create container, clear pool world. Okay, so this is for future stuff. We're not there yet, right? Clear pool game room. We're not there yet. There's nothing there. Get types on stage. This is using just for metrics. So this is what is being called for the that little this one here, which is the editor window. It calls this get count thing. So that's how we get the count, get type count. These are used for metric stuff. Get keys. Why do we need keys? What calls it? Oh, okay. Yeah. No, that's fine. That's fine. So this will need to be changed over. So that's old. The new one will be pool new dot keys, list all keys. Yeah, so that'll give us a list, and then we just return that list into our return statement. That's all we need to do for right now. Of course, I'll just comment that out. We'll switch over very soon to the new logic. Okay, we already went through that. We went through this. Okay, I think we're ready to give it a try. Yeah, I think we're ready to give it a try. But before we do that, I want to just run it while still not using that, just to make sure there's no weird anomalies. Okay, so that's fine. No match found for object file name. What is this? This is new. Did we break something? I think we did. I think we broke something. Okay, so under what condition does this come up? Mushroom sphere x what mushroom sphere? What is a mushroom sphere? We don't have a mushroom sphere. Where would that be getting called from? Let's trace that back. Why is it trying to load a mushroom sphere? What is even a mushroom sphere? I that's new to me. I don't see how this can all of a sudden exist. Or did it exist and I just never noticed it? That's possible. That is so strange. What is a mushroom sphere? What would be even considered as a mushroom sphere? And what is this object? Oh, there's our mushroom sphere. Wait, why do we have a mushroom sphere? What is this object that's on the stage? I don't think that's supposed to be there. What are we doing that's causing that to be created? This one here. But if it's disabled, why is it trying to execute logic? Okay, well, it's not crashing. It's giving us a warning, but still. I don't know what this object is. What's it supposed to be? So that would be pick up item, ground cube, ground cube. Okay, so we got 2 ground cubes. I'm not sure what that's supposed to be and why it's crashing. Or not crashing, but it's trying to run on start. Okay, so that would be a pickup item. So if we were to run this, okay, so that looks fine. But what is this mushroom sphere thing? Oh, huh. Our character ended up here. Yeah, I don't know what this mushroom sphere thing. It just started doing this weird behavior recently. I don't think this was there before. Maybe I accidentally copied something and didn't realize it. That's possible. But if it's disabled, why is the code running? Is what I'm thinking. Cube block S. How does it become a mushroom sphere though? Oh, that's a different object. Oh, that is definitely a different object. Okay, so that's why there's 12 of them. There's 12 of these things. Where did this appear from? And how did this come into being? Wow, okay. So this is new. Okay, so there's 12 of these. So we changed something that resulted in this. What did we change that resulted in this? And why mushroom sphere size extra small of all things? Variation ID 0. What caused the creation of this? So it's obviously script related. And it's being placed at position 0, 0, 0. So it's not this thing. This just happens to be on top. Very strange. How many of them do we have? Let's collapse them. 25. What do we create? What, because that's a very specific number that might help us better understand kind of what's going on there. So what are we making that there is 25 of inside of Game Room? We're creating something that there's 25 of. What is there that there would be 25 of? So ground blocks. That's only 20. That's not 25. So what would be bounding environment? I don't think that would be 25 either, because that would just be a wrap around these. I'm not sure what is causing it, but it's something is definitely causing it. So how are we getting the number 25? Only if there's a way to track this back before this point. Because this just tells me on start. But what created the start of this? I don't know. Seems very strange that it would do this now, though. Right when we went and modified the object pool. Okay. When we created the object pool, there's 25 objects that on start but what do we have that would result that? I'm not sure. Something is resulting in creating 25 of these. But what? If we look at it just based on order of creation, that may give us an answer. So ground cube, mushroom, ground cube, mushroom, ground cube, mushroom. I'm kind of seeing a pattern here. So after every ground cube, there's a mushroom that's created. Yeah, okay. But not these ones. And they're all nested. And what are these? Where's this object? Oh, that is these. Okay. Something's definitely wrong here. Because this is a non-selectable object. I don't see the handlers for this. Oh, they are there. They're just buried. Very interesting. Okay, so this just happened when we went and modified the dictionary. Sorry, not dictionary, the object pool. So before this, this wasn't the case. Okay, so if this is the case now, then that means we definitely messed something up in the object pool, because this is not right. These should all be parented under here. They shouldn't be outside of it. Like this is not right. Okay, let's look at this here. Ground cubes, 42. Okay, so that's incorrect. There shouldn't be 42. It's a 6 by... Oh, it's a 6 by 7. So that is correct, actually. So 42 is correct. Okay, pillars 2 is correct. Destroyable objects 1 is correct. Explosive bomb 1 is correct. And then 22 environment structures, and that would be these little rectangular blue mushroom thingies. So these are all correct. So then what is not correct then is all of these other objects. So this whole thing. But I can't select them either, which I find very strange. Oh, it's because they're static. Sure. No, I can't select them. They're static. Okay. So we definitely messed something up here. Could it be a Unity thing? Let's try that, because this is just behaving so strange. I'm just going to close that, and I'm going to reopen Unity, because that just seems so strange. It's worth considering that it might be a Unity thing. So I closed Unity. We'll just wait for it to reopen. Because sometimes Unity does behave strangely, and I find it strange that I can't select those objects. That doesn't make sense to me. Right? I should be able to, at bare minimum, select those objects and move them around. Or it should crash because I've done something wrong. It should be one of the two. So let's see, what result does this give us when we run it now? Same thing. It's giving us these static objects. But there's no errors. Just an output. But I can't select or move these objects because it's being shown as static. Do you want to change the static flag of all children objects as well? Yes. Okay, so then now I can move it. But that shouldn't be the case though. Why is it coming in as static? Are these static? Oh, okay, so these are static too. Okay. So then it is my code somewhere. So let's simplify this. Let's make it very simple, because that's the dynamic level that we have created. Here's what we're going to do. We're going to create a much more simpler level. Oops, I thought I grabbed all of it. So we will make a, let's make a 2x2. So we'll make a 2x2. And that's all we're going to make. And let's have a look at that. So there should be 4 blocks. That's it, nothing else. Everything else is removed. So with 4 blocks, they should be appropriately parented. And there we go, we got the duplicates again. Out of bounds. What do you mean out of bounds? Oh, right, of course. It should be, rows and columns should be 2x2. Two by two, elevation of 1. Yeah, okay. Okay. So yeah, there's our 4 original blocks. and then these that are incorrect. So we should have 4 outputs that say, nope, we got none. So how are these created then? How are these created? I just want to see if it's somehow accidentally being called twice. There was a crash on exit. What was that crash? Was on the recycle. Oh, of course. If framework instance equals, no, if it does not equal null, because what happened is because I'm using the because I'm using a singleton pattern, there's some weird behavior that I will need to kind of work around. So for right now, I'm going to continue with this path, but I'm going to try to, of course, find better solutions moving forward. For right now, I just need simple solutions. I don't need overly complex stuff. Okay, so let's see, how many times does that get called? So it gets called only once. These are the correct ones. How does these get created, these duplicates? I find that very interesting. Or is the logic doing exactly what it's supposed to be doing, and I am just not thinking it through? Yep. It's all me. Okay. Wow, I'm really not thinking clearly. I just added this code. I have duplicate code running, and I'm wondering why it's performing duplicate execution. Okay, that's my bad, guys. I was not thinking through. I just realized it now. That's why it's duplicate. And that's why one of them is basically centered and one is being used. It's because the code is being run twice here. So let's address that. So what we'll do is we will remove the old pool, and it's going to give us some warning messages. Okay, but we knew this, right? So we're going to remove all this stuff, or comment it out, I mean, for right now. Not necessarily remove yet, but we're going to comment out everything. Where's that other pool count? Pool count, pool count. Wait, if it does not, yeah, no, if it does not exist, we're not gonna call that. We don't need the count. If it doesn't exist, the count is going to be 0. Okay, so let's move down and just start commenting this stuff out. Okay, so that will get taken out. This was legacy. So right to about here, we will enable this. Okay, and we'll just go through it and take it all out. Get type count. Oh, I see. Okay. I guess we missed that one. That's okay. Simple fix. So we will return pool new count of object pool type. Get keys. Okay. We'll do that as well. Those will be for later use. Those can stay. This stuff is old. You can see what I meant earlier by it's really like we're going to take a lot out. It's going to be a lot cleaner. Okay. Again, more stuff to remove. This stuff will stay. The old function should have 0 references, so we could safely take this one out. And that is the guest star of today, the barking dog, yet again. Okay. And then in pool, or is in pool, should have 0 calls. Okay, so this has, okay, so this is old. Can remove that. Down here. This has 0 references. Can safely disable that. Down here, 0 references. Disable that. And the last one should also be a 0. That is a lot of cleanup. Like, that's going to be so much easier to manage. I'll clean the other stuff up later, but that's just going to make it so much better. Yeah. Okay. Now let's test it and see what we get. Okay, so no errors. And there we go. And everything is working correctly. And it's nested correctly. Controller is not connecting for some reason. Try enabling it again. Find that a little strange, but okay. There we go. Okay, so now that that's working, let's bring it back to where we were before I completely forgot what I was doing and made a duplicate and yada, yada, yada. Nobody saw that, right? Okay, glad we discussed it, that nobody saw that. This I don't need right now. what I want is game room. I want to revert this back. Okay. Oh, there's another error. What's this one? I see. Oh, right. That same idea. When I go to exit, if it's already being destroyed, then there's no point. So let's... let's put it here, I guess. That's not what I typed. Pretty sure that's not what I typed, but okay. If framework instance equals null, we want to return if framework instance dot event manager equals null, we want to return. Okay, so that should allow it to exit gracefully. Okay, almost there, almost there. Oh, haha, whoops, I forgot. I think my map was at 5x4? No, 4x5. 4 rows, 5 columns, yes. I forgot to change that back. Okay, one more try. One more try. Yes. Excellent. Okay. And if we look over here, not so great. Everything is 0 across the board. Why? So what is 0? Let's close that. Let's close some of this stuff that I don't really need right now. Let's just focus on this. So when this calls the values, get type count. Okay. So this is what's returning 0. If contains key equals false, return 0. Otherwise, return count. That seems correct to me. So how are they all zeros? The way that they would all be zeros is if we're not storing it when we create a new object, we're not storing it. Okay, that could be it. So let's have a look at this and see. When we go to, say, pool new, we create that, and we say store in pool immediately afterward. Or, no, not stored in pool. Yeah, stored in pool. What we do is we store it here, and we remove it from in use. Okay, so that's correct. That is correct. That is when we're adding to the pool. Now, if we're getting from the pool, what we're doing is checking pool key exists. Let's make sure the other one is commented out. Pool new and that. Yeah, okay. So then when we go and we call the get, pool key exists. If it's false, we tell it to create an empty one. Okay. I think this is it right here. We're not storing pool new. Okay, so we're adding the section, or so we're adding the category if it doesn't exist. Then if count equals 0, we create an object by type. So we're retrieving it. And when we retrieve it, we are get object by type. No, we should be adding it to the stage, shouldn't we? Oh, no. Okay. So I did make a mistake there. So when we get it, then we need to add it for tracking because it's going to be used on the stage. So we do need to track it. Okay. So we need to add it to tracking. And then if we retrieve, we also need to add it to tracking. So it doesn't matter if we create it, create a new instance, or if we retrieve it, it will need to be tracked for metrics of knowing what's on stage. So this and this, let's have a look at this again. Oh, I keep going back to the same one. Nope, don't need to see this one. Retrieve and remove. Retrieve and remove. What does this do? Okay, this adds it to tracking. Okay, so that's a double count. Don't need that here. We only need it in one location. Okay. So that way we're not double counting. So regardless of if we create a new instance or if we retrieve it, and if we retrieve it, all we're doing is we're just getting a reference to the next available one. Sorry, we're getting and removing it. And then we're returning the reference. When we return the reference, so either way, it ends up in this object or this variable. We track it, then we return it. Okay, that's why it wasn't tracking. So let's keep looking though. On the remove, pretty straightforward. We just call remove. Remove just removes it. I don't think remove is properly implemented yet. Okay, and then we have get keys and so on and so forth. Okay, so let's try that now. Let's see if that fixes it. It should hopefully fix it, though I think there might be some more stuff that I may have overlooked, but I'm hoping this fixes it. So we should see the correct count. Okay, there we go. So that's the correct count. All right. What is that notification? Okay, that's nothing. We can ignore that for now. That was for something else that I was working on. Okay, so then we can throw some popsicles. Oh yeah, those are not pooled yet properly, but these should be. Okay, so we're going to create a bunch of these. Okay, and then we're going to change the scene. So we have 10. We change it. There's 10 instances total, 10 in the pool. Okay. Okay, so we go to here. There are 13 total. So we used up our pool. We put 10 on stage and we created 3 new instances. Let's go and end this round and we'll go to the next one. So this is going to be the real test. Okay, so the numbers we're looking at is the destroyable objects. 17 instances total. All 17 are on the stage. Okay, so let's keep a look on the instances total. And what I'll do is I'll clear this stage. I noticed a little bit of a performance hiccup there. Okay, so now all 17 are in the pool. Okay, so what I'm going to do is we're going to create a couple more. Actually, yeah, we'll just create a couple of blocks, destroy them. So 17 went down to 15, 17, okay, so back to 17. So that's correct. So what we need to do, this is the real test here. We KO this player and see what happens. Okay, so we have 17 in the pool. All 17 should be used and no new ones should be created unless it's necessary for them to be created. So 17. And yeah. Wait, no. Nope. That failed. Right back to where we were before. So now we have 35 instances total. We have 16 on stage and we have 19 in the pool. That I really thought we would have solved that. But clearly this logical flaw goes a bit deeper than what I thought. Okay, so if we go cube a block, right? So that seems about right to me. So that seems like we'll say 16. And then we have 1 in the pool. So these extra references that it thinks it has are not correct. There's not 35 instances total. So it's double counting. Because 17 is what we had. We put 16 on stage, so we have 1 in the pool. So that means it counted an extra 18. That's unfortunate. I thought we solved that. Okay, so the question is, what is happening that's resulting in that miscount? Because it's clearly the miscount of this dictionary usage. So let's have a look at that again. So when we go to add it to here, when we go to add it to the dictionary and we check stored in pool, actually, let's see, was there any errors? Yeah. Key does not exist. Let's have a look at that. Store in pool. Where's that called from? So on the add, we're getting some outputs that are potentially the cause. So if we go to add it, we add it to our pool, but then because we added it to the pool, we notify this internally that it's stored in pool. So we reparent it, and then we remove it from the ones on stage if it exists. It may not exist if it was freshly created. Okay, so let's check that. So if object in use dot if it exists equals true. So let's check if it exists, right? That way we have a bit more validation control over it. So iPoolable object dot game object dot get hashcode. Okay, so that should get rid of that one warning. That's not going to fix it though. Okay, so on the add, go here, check if it exists. Sorry, that's debug. Add, we'll add the category if it doesn't exist, and then we'll add this to the type. Then we call store. Okay, so that we've looked at it. On the get, if key exists equals false, the debug will ignore. If key exists equals false, key exists for the type equals false, we create the category for the type. Okay, so after this, the category should exist. If it didn't exist, it'll exist now with a value or with a total count of 0. So we check. If count is 0, we want to create the object by type. Okay, so if we create the object by type, what does that mean? Okay, so we call this thing. That's fine. This has no tracking stuff, right? Let's go to one of these. No tracking. Okay. So if we create object by type, that's pretty obvious. Store the reference in this variable. However, if it's not equal 0, so if it's greater than 0, then what we want to do is we want to retrieve it. What does retrieve entail? We go to pool new, get and remove index position 0, and then we return it. So pretty straightforward. And then once we have the reference, we considered an object that is going to be added to stage, so we track it. So we add it to our tracker. Tracker takes the object, stores it by the hash code, and then stores the iPoolable object reference, and then returns it. We don't use the return value because we already have it. And then we return it. There's no other code there. Okay. Remove. Remove object reference. What was the old one? The old one removed it from the tracker. Right. And I think that's what we're missing. I think that's it right there. Okay. So if, let's do a check here. If object in use dot key exists equals true, so we need the object pool type, and then we need the object dot game object dot hash code. If it equals true, then we remove it from dictionary objects in use dot remove iPoolable object type, and then iPoolable object dot game object dot get hash code. Okay, so I think that's why it wasn't working right there, but let's keep looking though, because there might be some more flaws that I may have overlooked. Okay, so that's the remove. And then there's the get key, so that's pretty straightforward. Count is pretty straightforward. Get count on stage, so that's straightforward. And then that stuff is fine. Construct, no problem. Destroy, clear. Yeah, I think that was it. I think that was it right there that we just fixed. So let's go back and run that test again. I think we may have solved it. I'm not sure. We'll see. But we're also kind of running a little bit low on time here. For those of you that are new, hello and welcome to the broadcast. I do development on Tuesdays and on Fridays. So this is, of course, my Friday evening broadcast. I'm working on a project that I've been working on for quite some time. I work on this on my spare time, casually. Let's place a few. Okay, and then we'll change the scene. Okay, so we have what are we looking for here? Environment structure, no. Destroyable objects. So we have 10 total. So let's keep that in mind, 10. So yeah, I work on this project quite regularly on my spare time. It's fun, it's educational for me, and I like sharing it with you guys. You're welcome to jump in to my broadcasts at any time or watch the archived ones on YouTube. And feel free to say hi. I don't mind. Or if you have questions or whatever the case may be. I do this just as much for you guys as for me. It's to learn from it for me, from my side. It is to learn. So objects now is up onto 10. Let's end this round and we'll go to the next one. But yeah, so this is a project that I'll be working on for quite some time because it's a fairly large project and it's really good opportunity for me to learn because otherwise I wouldn't utilize this skill set, and this is a skill set that I enjoy. I think there's a lot of value in it personally, not just entertainment for me, but it's something that's really fun to do. Okay, so now our destroyable objects count is up to 20. So I need to clear them all, and you'll see me just run through and just clear everything, and then I'll KO the other players. But yeah, this is something that, so I'm porting it over from the old Flash version to take pretty much as much of the logic as I could. But then this is going to be number 2. So we will be deviating away from that. And currently the game type, of course, is classical kind of Bomberman. There's a lot more to the project. When we get to the world part of it, there's pets and the pet combat system and whatnot. So it's going to be really fun. I'm looking forward to working on it in Unity because it's so much more powerful than Flash ever was and ever would have been. So it's going to be awesome, and it's going to be cross-platform compatible. It'll work on mobile devices, so it'll work on touchscreen. It'll work on mouse and keyboard, and of course gamepad, which is what I test on mostly. I don't know how well you can see that. I know my camera's not great, but yeah. Okay, so this is the test. I don't have any destroyable blocks. Okay, I'll wait for the power-ups and see if I can get any, because that seems to be one of the potential causes of it. Okay, so I got 2 destroyable blocks. We'll put one there, put one there. And we'll go on, oops, I thought I put it right between them. I guess I'm wrong. Okay, so at this point then I can KO the other players and see if it works. So if it works, it works. If it doesn't, then that means there's still something that needs to be fixed. So this is the moment of truth. So let's look at this number. Destroyable objects, we have 20 instances, 0 on stage, 20 in the pool. So it should use the pool and deplete the pool to create the next round. So let's see how that goes. And nope, didn't work. Wow. I'm just not having any luck with solving this bug. So it thinks that there's 40 instances total, which is not correct because there was 20. Now it went up by 2. So now it went from 20 to 40. So, but there's really 16 on stage and there's 4 in the pool, and we can see that here by the filter that's currently active. So that's about 16, and then that's 4 right there that's in the object pool. So that means I still haven't solved this. Wow. Okay. Okay, that's fine. My feelings are a little hurt, but okay, that's fine. Let's have a look at that. So where's our total? Total is in pool. Wait, that's not right, is it? Total is objects in pool and in use. No, that's fine. That's fine, because we're resetting the values. For a second there, I thought I was adding them on every iteration of the loop, which is not correct, of course. So in pool, we get a fresh value. In use, we get a fresh value. Total count, we add the ones in pool and in use to get the total count. And then we display the total count. And this is the value that's incorrect, and it comes out as double-ish. Not always, but it does seem to come out as double. Not exactly sure why. Not really sure why. Why do you come out as double? Okay. So in use calls this and gets the count. What is count? If it does not exist in the key, it returns 0. If it does exist, it returns the value. Okay. That's fine. And then the other count is the in pool. Pool new should do the same thing. If exists, or sorry, if it doesn't exist, it returns 0. If it does exist, it just gets the count from it. Okay, so that looks fine to me. And then it takes both of them, adds them together, and we get the total. I mean, I could do toString. Maybe it's, I don't know. Could do that too. I don't think that makes a difference really. Because the other ones, they don't double. So we have in use. This one seems to come out correct. Pool is the one that comes out incorrect. So let's focus on that one. Why is that coming out incorrect? Get type goes to here. So that means this count is incorrect. Why is the count incorrect? How is the count incorrect? It's a good question. I'm not sure I have an answer for that. I mean, I have theories, of course. I have theories, but as an exact answer, I don't know if... wish I knew. So what else can we try then? We did remove a whole bunch of code. It's stable, but the result is the same. So that means the same logical flaw that existed before got carried over. So what's happening is that it's the remove. It's the get or the remove or both. When we say remove, we check, but it's not this though, it's this. So let's look at this one. Every reference to this dictionary, let's look at it. Okay, so that's initial creation. Okay, that's just a count. This one is store in pool. If we store it in the object pool, we want to remove it from this. So if key exists equals true, we remove it by the game object hash code is how it's stored. Okay? That looks about right. Game object, get hash code. Okay, moving on. So add object to tracking. When we go to add it, we add it by the hash code and we store the reference and then we return it. Okay? Next reference. Remove object reference. Didn't we already look at this? store in pool, we remove. Wait, then why do we have a remove? I see. Okay. One is if it's stored in the object pool, we want to remove it from this metrics dictionary. The other being when we remove object reference to. Not sure I understand that one, but okay, we'll look into it. So if it exists, and only if it exists, we remove it by the hash code. So what calls this? Oh, that's from straight from remove. Okay. So that would mean that, no, that doesn't make sense. So I don't think we're using this reference. No, I'm pretty sure we're not using that. We're using primarily this one, the add to object pool. So when we add it, we say stored in pool. Goes to here, reparents it, checks if it exists in that dictionary, we remove it. If it doesn't exist, then we don't need to do anything. Retrieve and remove. What is retrieve and remove? Retrieve and remove. We just need to do that. Add to stage for tracking. Yeah, we don't need to call that. I guess the common factor here is for getting the duplicates is this add stage object to tracking. Okay, let's try this. Debug.log, and we'll color change it. So we'll say generic functions dot format text color. We'll have our message, and then we will color it. Let's go with color violet. Sure. And we'll just put this here. And then we will say the iPoolable object dot type. And then iPoolable object dot game object dot name. I want to see the name specifically. Actually, while we're at it, let's get the hash code too. Plus iPoolable object game object dot hash code. Okay. That's going to output a lot, but let's see it anyway. So let's see what we get. I am running out of time here for today. I was kind of hoping I would solve this, but apparently it doesn't seem to be that easy to resolve. Okay, so Oh, it's still collapsed. Let's uncollapse that. Is it? No. Oh, I shrank that. It's my bad. Okay. So when we go to add to stage, the tracking is, oh. Why is the hash code in the negatives? That is very interesting. Why would it be in the negatives? Okay, that's fine. That's fine, either way. Okay, so we got a bunch of stuff tracked, so we know that they exist. So we're looking at destroyable objects again. We got 4 gray blocks and 1 blue one, so that's 5 total. That's correct. Change scene. 5 still remains. They got removed from stage to pool. There's no... Okay, let's log in. It's interesting how they use negative numbers, because that's not me, I don't think. I think they're using negative numbers for some reason. I find that a little strange. Okay, so what we want to do is go to the next round. Okay, so the count is still correct, 1717. So really where it messes up is when the pool is empty. What if it's not empty? Or sorry, when the stage is empty. Let's KO these players, and we'll just go straight into the next one, and let's watch this number. What happens here? So if it's 17 on stage, 0 in the pool. Oh, well, that's interesting. So it rebuilt correctly. So if they're in the pool, it doesn't use them. Or sorry, it doesn't count them correctly. But if they are out, that doesn't make sense. I don't get it. How did I butcher this logic? Oh, hey there, Mr. Cog 3D. How are we doing today? Sorry, I'm late. No worries. It's understandable. I'm not having good luck with resolving this bug that I've been having. I think I'm gonna have to sleep on it and address it tomorrow. So, from the looks of it, it's miscalculated thought you fixed that. No, I was in the process of fixing it. Um, I was really on track and I thought I had the right solution, but I've been trying a bunch of things and I did move some of the logic over from the old method into the newer logic that I want to move forward with in terms of direction of how the object pool system works. But the same flaw still exists. So it's a logical flaw that I don't understand because it's just being measured incorrectly, but it works out fine, but it's measured incorrectly, which is really strange. So if I KO and we KO, now we have some mix in on the stage. We have 9. In the pool we have 8. So total we have 17. So let's see what happens when it builds the new round. Okay, so yeah, it messed it up again. Wait, no, that did work. So it worked this time. So we have 3 spare. No, it is wrong. We have 2 spare. We don't have 3 spare. We have 2 spare. So the destroyable objects, so in the pool, it's saying 3. It's actually 2. Okay, so if I clear it, I think I'm getting closer though, because it's when I clear the stage. That's interesting. It just kind of didn't want to place an explosive. That was very strange. So when I clear the whole thing, the count gets messed up. But the pool is correct. Otherwise it would crash. So I find that very strange. Okay, so right now the pool says 20 in the pool. Okay, so if we have 20 in the pool and we have 0 on stage and we have 20 instances total, I believe that is correct. So this I think is 20. I'm not going to count it. So what I'll do then is I will KO this player and KO this player and see what the total is that we get. So the total is destroyed. Wait, how did it go up to 21? Did I miss a block? I must have missed one. Okay, so instances. Yeah, so that's the miscount right there. 39 instances total. That's not correct. 16 on stage, I'm sure is correct. 23 in the pool is not correct. Because if we look at this filter, right? So this filter that's active is telling us that there's only 1 in the object pool. The rest are being utilized on stage. So this 23 in the pool is off by 22. It seems to be I thought I solved it. Clearly not. Okay, so it is the count that is the total, which is the ones in the pool in use together give you a total count. But if the ones in the pool are wrong, then the total count's wrong. The in use is correct every time. The ones in the pool are wrong. The ones in the pool are wrong. So how though? Okay, so that just returns a count. That's not doing anything. Remove checks if it exists equals false. It doesn't do anything. If it exists, it removes the index. Let's remove index and then remove object. Same idea. Checks if it exists, removes the object. Clear is clear. Okay, so this, I don't think it's that, but the count that's wrong is the pool count. Pool count, how is this wrong? Where do we get the count? Right here. This is the count that's wrong, but how is the count wrong? Because on get, the category doesn't exist. We create it. If count of this category equals 0, we create a new instance. If it's greater than 0, we retrieve index position and we store the tracking. Okay, so let's look at retrieve again. Retrieve, we use get and remove. So we check if it exists, false, we return null. If it does exist, we get the reference using the index position, and then we remove that specific index position and then return the object. Okay, that's fine. Return it here. This returns it back to where we called it, and then we track it. So this tracking is correct, but it's when we go and create a new stage where it fails. Instead of the count being correct, it somehow gets thrown off. And that's what I don't understand. It's unfortunate. I was really hoping I could solve this tonight. I'm just not in the right mind state for tonight. I will not be solving this tonight. I will have a good go at it tomorrow, but for today, I don't think it's going to happen. How would this count be off? And off by so much. It's like it doesn't even use this. It's like it doesn't use it at all. So if I was to go and clear this level, clear all the destroyable objects, we don't have much time, so I'll try to do it before the clock runs out. Okay, so all of them have been cleared, minus this one. You can see those weird stutters, right? Okay, so all have been cleared. I'll KO this player. So we have 0 on stage, and it says 38 instances in the pool, which is not correct. That's not 38. That is not 38. Okay, so let's see what happens. It won't use the 38. It'll add on, yeah. So it went and created, but it didn't create though. It used of that, so it used 16, so that means there was 17. We have 1 in the pool, right? So this 35 is off by 34. It's just a count that's off, which I find very strange. How can the count be off? Because I'm not doing anything weird with the numbers, but the count is off. There's only 1 in the pool, but it's telling me there's 35 in the pool. Yeah, I don't know. I don't know. Okay. I need to get some good rest and think about it. And then I'll have a good go at it. And likely by the next broadcast on Tuesday, it will be resolved and I will have moved past this. Actually, I'm quite confident that I will solve it. It's likely something really, really minor. That's why it's so easy to overlook. I just haven't been looking at this thing with a fresh mind. It's been, work, and then put a little bit of time towards this when I can, and not enough time to really dig into it with a fresh mind, right? So I think some good rest, and then I'll be able to, I think, put a bit of time on it on tomorrow, if not Sunday for sure. So I'll make some good progress on it then. Anyway, I think I'm going to call it for today, though. So for those of you that are here, thank you for watching the broadcast. I appreciate it when you guys come and hang out. You're welcome to say hi during any one of these broadcasts. I don't mind. I actually prefer that. But also you can watch the broadcasts that are archived on YouTube if you want to just glance at any of them. I do write dev journals periodically, which can be found on the official forum for the project. And there's also Discord, Twitter, and Instagram if you're interested into that kind of stuff. I'm just throwing it out there. All of those links are available on the official website. But that's going to be it for me today. So thank you for watching. Have a great day or evening, and have a great weekend. I'll see you guys next week on Tuesday. Bye.